Cri-du-Chat syndrome, or CDCS, is a rare genetic disorder caused by the deletions in the P arm of the chromosome 5. The following phenotypes are observed for individuals afflicted with this condition: high pitched cat like cries, hence the name of the condition, facial dysformisms, and both psychomotor and mental retardation. The cat like cry is thought to be associated with FLJ25076 UBCE2 gene found in the 5p15.3 region, whereas the facial dysmorphisms, psychomotor impairment, and mental retardation are thought to be associated with genes such as delta catenin and semaphorin F, and others found in the 5p15.2 region.
If you think of cars as the enzymes of the body, the road to be your DNA, and the destination to be a protein product, your car wouldn't be able to reach the destination if the road is missing or if some parts of the road is ruined. In the topic of genetics, that's called a DNA mutation. However, there are other ways to stop the car from reaching a destination. For example, if the road has a traffic light that's indefinitely stuck at the red light, then you also won't be able to reach your destination. Similar to that, autocredushat is caused by the partial deletion of chromosome 5. Some of the associated symptoms related to the syndrome may be due to just the addition of methyl groups. In 2017, using genome-wide DNA methylation profiling in a regulatory element in Kudushat syndrome, it was determined that there were 54 genes in the affected patients that were either very abundant of these methyl groups or very lacking of it. Out of these 54 genes, there were 18 that were known to have important roles such as for growth factor stimulus, embryonic development regulation, and organ formation. It was also observed that aside from the well known cat like cry, people with Kidushat also manifest autistic symptoms such as severe mental retardations and behavioral problems. This drove researchers to investigate the correlation between the two, and by 2009, a genome wide association study was able to reveal that 96 single nucleotide polymorphisms in the 5P were associated with high risk of autism and other social communication phenotypes.
Microcephaly is another clinical feature of CDCS. In 2019, Kahimi and his colleagues performed a genomic array using 850,000 SNPs and found that the genomic region 4.7 megabases is associated with the manifestation of microcephaly in patients. This is in line with the suggestion of Emalki in 2014 that the terminal region of 5.5 MB found between 5p15.32 to 33 regulates the growth of the head and other dysmorphic features. Currently, there is no cure available for this syndrome. Treatments are focused on managing the symptoms, and approaches include early and consistent educational intervention, physical, language, and occupational therapies.